In this example, we will evaluate the series in two different ways. The first way, use a telescoping series argument. Second way, use a geometric series argument after first simplifying 1 over 2 to the power k minus 1 over 2 to the k plus 1. To use a telescoping series, we're going to use the n partial sum, which is Sn. For the first term, or n equals 1, with 1 over 2 minus 1 over 2 to the second. For k equals 2, with 1 over 2 to the second minus 1 over 2 to the third. For k equals 3, we get 1 over 2 to the third minus 1 over to the fourth, and so forth. And then the very last one, which is the n term, would be 1 over 2 to the n minus 1 over to the n plus 1. The one before the last is 1 over to the n minus 1 minus 1 over 2 to the n. Look for the terms to cancel. See, negative 1 over 2 to the second, 1 over 2 to the second cancel. Negative 1 over 2 thirds, 1 over 2 to the third cancel. So the terms that next to each other cancel out. And Sn is simplified to be 1 over 2 minus 1 over 2 to the n plus 1. And then we take the limit as n approaches infinity. So the limit of the Sn, n approaches infinity, which is in the form of the limit of 1 over 2 minus 1 over 2 to the n plus 1. N approaches infinity equals 1/2. And this is the value of this series by using the telescoping series argument. The second way to evaluate this infinite series is to use the geometric series. First, we're going to simplify the expression 1 over 2 to the power k minus 1 over 2 to the k plus 1. 2 to the k plus 1 is the same as 2 to the power k times 2 to the first. So multiply the first fraction by 2 over 2 to get the same denominator as 2 to the power k plus 1. And numerator becomes 2 minus 1, or we write it as 1 over 2 to the k plus 1. And which is the same as 1 over 2 times 2 to the k. Now the summation becomes 1 over 2 multiplied by 1 over 2 to the power k for k from 1 to infinity. And using the geometric series process, we're going to identify the first term a. The first term a when k equals 1, which is 1 over 2 times 1 over 2 to the first power, or 1 over 4. And the r, or the ratio constant, which is the number raised to the power k, which is 1 over 2. Since the absolute value of the 2 is less than 1, we can use the formula to find the value of this series as a divided by 1 minus r. A is 1 over 4 divided by 1 minus 1/2. Then we get 1 over 4 divided by 1 over 2. And we write it as 2 over 4, or 1/2. Use the same conclusion that the series converges to the value 1/2, which is the same result as the way that we use the telescoping series argument.